Hello everyone. Today I'll be walking you over the firmware development platform using MIPS processors. So we'll be using the Gem5 to run the firmware code, and we are using the MIPS processor model for executing the firmware code. So the old sequence is as follows. When we start the simulation from VisualSim side, we generate a Gem5 start trigger. So the start trigger will be accepted by the Gem5 wrapper and through this start trigger port, and then it will trigger a script called run-script.py, which is present in the Gem5 folder. So if we go to the Gem5 folder, there is a run-script.py placed. So if you look at the run-script.py, we can see that it is using the MIPS Gem5 build, and these are the arguments that I am passing. So I have the arguments that I am passing include a provision to enable the debugger hook, and I am defining the caches. It also the L2 cache defined. The L1 D cache is of 32 KB size. L1 I cache is also of 32 KB size. L2 cache is of 56 KB size. And so depending upon the model that we want to simulate, there are different provisions provided. In this configuration script, I am using a simple timing CPU, but which is an in-order CPU. But there is also an out of order CPU that the user could use. So, and here we have the workload. So the binary for the workload or the source code has to be provided in here as this argument. So so let us say we have a source code, then you can compile it using the MIPS cross compiler, and it has to be little endian. So that is something that we have to make sure. And because Gem5 only accepts little endian. So if using the cross compiler, user can set the target architecture and compile it accordingly. So the mark argument can be used while compiling to specify the target architecture, whether it is MIPS32 or MIPS64 and any others. So from the supported type, user can select it, and then user also need to add the -g argument to enable the debug signals, the debug symbols to be loaded, and also -static. It has to be statically linked. So once you compile it using these settings, the binary will be ready to be executed on Gem5. So now let me take you to VisualSim. Let me run the simulation. So essentially, now we can see that I have a new pop-up window coming up, and from the messages displayed here, it is now waiting for remote GDB connect on port 7000. So the VisualSim model is also waiting. We can see the data from the Gem5 will be all the memory accesses and the peripheral accesses will be coming over to VisualSim. So when all of them will be coming over, all the data access will be coming over through the Gem5 wrapper from Gem5 port. So once it comes over to the VisualSim site, it has to go over the PCIe bus, and we have the register is located here. So it will come over here. It will either read the register value or write the register value, and then it is going to send either the data or acknowledgement back to Gem5 through to Gem5 port. So to make it work now, we have to connect the GDB debugger. So let me execute the command here. So this is a command ddt -hyphen debugger gdb multi-arc and the path to the binary. Okay. So now what we need to do is let us try. We need to connect it to the gem file. So we have to type target remote localhost 7000. So now the connection has been made. Now we need to set the breakpoint. So let us add a breakpoint for this one of the lines in the code. So to count the line, let me go to the workflow. Okay, let me add the breakpoint for line number 7. So let me go back. Break, then workload.c colon 7. Okay, now I have added the breakpoint. Now I can just continue the simulation to proceed. So I can type in the command continue. So now the the transactions will be going across VisualSim. From VisualSim, it will read the data and send it back to Gem5. We can see it is proceeding. So once the breakpoint reaches, we'll be able to step through or view the variable values and display all the local variables. We can do all the commands here from this terminal. So let us give it a give it some time because it will take because we have to reach that breakpoint. Until then, all the memory accesses, all the data accesses for all the load store instructions will be coming over in the VisualSim side, and all the peripheral access will also be coming from to the VisualSim side, and it will read from the register and get the data sent back to Gem5. So it will take some time. So I will skip this part and take you to the final uh, results when the breakpoint is reached. So now the breakpoint has been reached, which is within the for loop. Now we can do the step and go line by line. So it will take some time as for each line to be executed. There are lot of load and store operations which are happening in the backend or in the processor side. So the processor will be showing those read or write accesses, and all those accesses are coming over to VisualSim. So it will take some time for a single step to complete. So we will wait until it completes. Okay, and now one step has been over. Now I can do another, the next step. Okay, now I can look at the variables. Let us say I can use the command info locals. I can see the value of variable I is 1, and the array is pointing to this location, and we have a sum which is 0 because we have not started updating it yet, because it is a first for loop, so we are not updating the sum. Only the I and the array values are getting updated. So let us step again. So now let us again check the local variables. Info locals, and let us try to print out the value of array. So I will say print array of 1. We can see the value 2000. Now let us continue to the end of execution. So here we can see this is towards the end of the source code execution. So here we can see on the command line, let me scroll up a bit. Yeah, the sum of array, the value has been printed onto the command line as mentioned in the source code. The sum of array, it is printed in the command line. So, and even after that, there are still, the wrap up, the cleanup functions are being executed. That is why you can see there are still memory accesses being executed. The processor is still executing the last couple of instructions. So the results, the printouts that are added in the source code will be displayed in this terminal. So these debug logs will be suppressed. So the user would only have to view minimal messages. So the printouts will be easily visible at that point. So please let us know if you have any questions or doubts. You can contact us by writing an email to info@mirabilisdesign.com. Thank you.